octagon PQRSTVWZ is a regular octagon with its center at point C. Remember, a regular anything means that all the angles are the same and all the sides are the same. So if I have an octagon that's 8 angles, 8 sides, we need to figure out which each angle is. So if I did that on my calculator, I'd get 45 degrees. So that helps me out because I'm going to select each correct transformation, probably more than one, and I'm going to select which ones would still look like this octagon. So if I reflect over QV, so if I connect QV, I see that it goes through the center. And if I reflected over that, it would just be kind of like, it would be the same thing. S would end up over here. R would end up over here, S over here, T over here, and vice versa. So this one works. Reflecting over RW. So let's see, R to W goes through the center. So that one also works. Reflecting over TZ. I'm looking at TZ. That does not go through the center. So if I reflect over that, it would not end up looking the same. So that does not work. Rotating 45 degrees clockwise around point Z. Although rotating 45 degrees would work, but it's not around the center. Point Z is here, so that would not work. It would have to be around C. All right, rotating 135 degrees clockwise around point C. Well, we already said 45 degrees, so what we would need to do is take our calculator and divide it by 45 to see if it comes out to be a whole number. If it came out with a decimal, wouldn't work. But this one actually comes out to be 3. So yes, this totally works. I would just, the R would end up 1, 2, 3 over there where V is. Okay, rotating 90 degrees clockwise around point C, or counterclockwise. So once again, I would take 90 divided by 45. I get 2, which is a whole number, so that works. That would mean Z would end up where V is. 2 cylinders, each with the height of 50 inches, are shown. So if I'm looking at these cylinders, I don't know what their radius is. I know the height is both 50 in each of them, and we're talking about this height in S. Since this is an oblique one, we're not talking about this part. All right, which statements about cylinders P and S are true? Select all that apply, meaning probably more than one. So if X equals Y, meaning the radius is the same in each one, the volume of cylinder P is greater than the volume of cylinder S because P is a right cylinder. That doesn't have anything to do with it. As long if their heights are the same, the radius is the same, then the volume is the same, no matter if one's right and one's oblique. So this one does not work. If X equals Y, then the volume of cylinder P is equal to the volume of cylinder S because the cylinders are the same height. Yes. If X equals Y, the volume of cylinder P is less than the volume of cylinder S because cylinder S is slanted. No, they are the same. We already said they were the same. Now we change things up a little bit. If X is less than Y, so if this radius is smaller than this radius, the area of the horizontal cross-section of cylinder P, which would make it a circle, okay, is greater than the cross-section of S. Okay, well, if this one is smaller, if the P radius is smaller, then that would mean this cross-section area is smaller than the other one. This one said that it's greater, so that does not work. if x equals y, the area of a horizontal cross-section of cylinder, I'm sorry, if x is less than y. So same thing as in D, okay? It's saying that the cross-section, the area of cylinder P is equal to cylinder S. No, this one would be smaller if this radius is smaller. So that doesn't work. F says if x is less than y, same thing as in D and E, the area of this cross-section in P is less than the area of this one. Yes, that's what we've been saying. Triangles ABC and DEF are right triangles as shown. Triangle ABC is similar to triangle DEF. That means the angles are the same, the sides are proportionate. It means one could be 2/4 and the other one could be 1/2. If we set up fractions, they're proportionate. Means if I reduced one, it would be the other one. So which ratios are equal to sine of C? Select all that apply. So, meaning probably more than one. So if we do this, we know that sine is opposite over hypotenuse. So let's look. We don't have any side numbers. So what we're going to do is we're going to name these sides. So if I'm looking at C, my opposite of C is this, and my hypotenuse is this. So here's my opposite, here's my hypotenuse. So I would have to have AB over AC. But why do we have this other triangle? What does that matter? Well, since the angles are the same, their signs are going to be the same. So the sine of this is going to be, and if I look up here, F is my corresponding angle. It's going to be the same as the sine of this. They're going to be the same. If this angle was 38 degrees, this angle would be 38 degrees. Sine of 38 is the sine of 38. So let's look at my opposite of F. That would be DE. And my hypotenuse is this right here, which would be DF. So those are the only two that are equal to the sine of C. So let's look for that. So we have AB over AC, that's it. This one says AB over BC, not yet. BC over, so BC is our adjacent side, so we can get rid of those. Now we're moving to the other triangle. So DE over DF, yes. They have side EF in this one, so that doesn't work. Also, again, side EF. So we have this one and this one that is. A landscaper is designing a display of flowers for an area in a public park. The flower seeds will be planted at points that lie on a circle that has a diameter of 8 feet. The point where any seed is planted must be at least 3 feet away from the seeds on either side of it. What is the maximum number of flower seeds that can be planted using the design? So let's go back and look. It will be on a circle. So we're going to make a circle. Okay, the diameter is 8 feet. That will help us. Okay, and they must be at least 3 feet away. So they can be more than 3 feet away, but they have to be at least 3 feet away from each side. So I know that my diameter is 8. We need to know how much around that circle is. So that's called the circumference. It's like the perimeter of the circle, but we call it the circumference. And if we remember, that is 2 pi r. And if our diameter is 8, what is our radius? So that is going to be 4. So 2 times 4 is 8. This is just a coincidence. It doesn't have anything to do with the diameter. Okay. And so 8 times pi is about 25.13. Now, how many feet away does it have to be from each other? 3 feet away here. So what we're going to do is take 25.13 and divide it by 3. And you get about 8 point something. Okay? So 8 point something. So they're going to, we can't have like half of a seed. So we can only have 8 plots around here. So like 1, 2, 3. So eight around that. So in this problem, we have the same landscaper, same circle. So part B says, after planting the flower seeds, the landscaper has 20 seeds left over. The landscaper wants to plant all the remaining seeds in another circle that the seeds are 2 feet apart. To the nearest tenth of a foot, what is the diameter of the smallest circle the landscaper can use to plant all of the remaining seeds? Well, first we're going to figure out what the circumference would equal. We don't have our radius, so we can't do 2 pi r, but we know we have 20 seeds 2 feet apart. So if we multiply that, we have 40 feet. That means our circle would be 40 feet around. Okay, but we now need to find the diameter of this circle. So if you remember in the last question, we had the diameter, we got the radius, then found the circumference. Well, in this one, we know what the circumference is. We also know that our circumference is 2 pi r. Well, we can find our radius by plugging in what we know. We know our circumference is 40. So we're going to take this, and we want to solve for r, which means we've got to then divide this whole thing by 2 pi. Well, this would just cancel out. 40 divided by 2 pi is about 6.4, okay? So that's our radius. How do we find our diameter? Don't stop at the radius. It's not asking us for that. It wants the diameter. So remember, our radius is just half of our diameter. So if we multiply this, we get 12.7. And if we put feet, because we're using feet here, okay, this would be our diameter. A queen-size mattress is 20 inches longer than it is wide. A king-size mattress is 16 inches wider than the queen-size mattress, but has the same length. The area of the king-size mattress is 1,280 square inches, more than that of the queen-size mattress. Part A, write an equation that can be used to determine the area of the king-size mattress. And then also it says define all variables used, meaning tell me what these things mean. So this is a lot going on here. We're going to break this up. It says a queen-size mattress is 20 inches longer than it is wide. A king-size mattress is 16 inches wider than the queen-size mattress, but has the same length. So we don't know anything about our width of the queen-size mattress. So let's draw our queen-size mattress. So if we have this here, this is our queen, okay? And if we're laying on this, this is our length, and this is our width. Well, we don't know anything about that width, but we do know that the length is 20 inches longer than the width. So if we do this, then there we go. We have that. We could, and it also says, hey, define our variables. So we would say W equals the width of the queen. All right, you have to give all the information it's asking for. All right, so now let's draw out our king size mattress. So we know the length is the same, but the width is even longer. So here's our king. Here's our person. We know that this is W plus 20 because the length is the same. And then what did it say about the width of it? The width is 16 inches wider than that of the queen. So that would be W plus 16 because W is the width of the queen. All right. Now it says Write an equation that can be used to determine the area of the king size mattress. So if I know that how to find the area of my queen, because it is the area of the king size mattress is 1,280 square inches more than that of the queen size mattress. I gotta figure out what the area of the queen size mattress is. So I know it's length times width. So area of queen. We could also say AQ, okay, equals length times width. Okay, and then the king is 1,280 inches more than that. So I could say AK, and over here I would define my variable. That would be area of king. Would be what this is, what my area of my queen is, plus the 1,280 inches. So what is it asking? It is asking us to write an equation that can be used to determine the area of the the king size mattress. So there is our equation that we answered part A. For part B, it says determine the dimensions of the king size and queen size mattresses. Show your work. So now we're going to have to put some numbers to it. So I know that this is the area of the king size mattress, but if I'm looking at my king dimensions up there, remember it's just length times width for my area. I have what my length is and I have what my width is. So that could also be an equation for the area of my king size mattress. So now that I have two equations, I could make them equal to each other, and I could solve for W, and then it makes it easy. I just plug everything in for W and find what they are. So first of all, we're going to go ahead and multiply each side out. So this side, if I FOIL it out, I'm going to get W squared, and outer is going to be 20W. Inner is 16W, and the last is 320. And so that's going to give me W squared plus 36W plus 320. This is Algebra 1 stuff. Don't mess up on the easy stuff. Equals, so I'm now going to simplify this top part. So multiplying W plus 20 times W just gives me W squared plus 20W plus 1,280. I'm going to bring it down here so it'll all be in the same place. So now I just have to get everything combined. So if I see that I can subtract W squared over here, that makes that go away. And hey, W squared minus W squared, that goes away. So now I'm going to take this 20W and subtract it over here. That goes away, and I get 16W. And then I'm going to subtract 320 from this side over here. So that goes away. And I get, let's see, 1280 minus 320. I get 960. I'm solving for W, so I'm going to divide by 16. And that gives me 60. Okay, so now I have what W equals. That helps me so much because the area of my queen, which I already said right here, was W plus 20 times W. So if I do this, because I'm looking, actually I don't even need the area. This is a good time to talk about this. Go back and see what it's asking. It says determine the dimensions of the king size and the queen size. So queen, if I spell it correctly, we have the length and we have the width, right? So our length was W plus 20. Our width was W. I haven't didn't have anything. So our width is going to be 60. Our length is going to be 60 plus 20, which is 80. Now we're going to find our king. We know the length was still W plus 20, and our width was W plus 16. So now we're going to add those. We're going to put 60 in its place. So 60 plus 20 is 80. And we're right because the lengths were the same for each mattress. And 60 plus 16 is 76. So this is our answer. If you remember, we did this one in class together a few weeks ago. So a billboard at ground level has a support length of 26 feet that extends from the top of the billboard to the ground. A post that is 5 feet tall is attached to the support and is 4 feet from where the base of the support is attached to the ground. In the figure shown, the distance in feet from the base of the billboard to the base of support is labeled X. Create an equation that can be used to determine X. Discuss any assumptions that should be made concerning the equation. Use your equation to find the value of X. Show your work and explain your answer. The first assumption we're going to make is that this is a right triangle. So if this is a right triangle, this is also a right triangle. So let's go ahead and put in the other information they told us. So we have the 26 already here. That is our support. And so we have a post that is 5 feet tall. So that would be here. And then it says that it is 4 feet from where the support hits the ground. So that would make this 4 feet. All right. And we want to find X. So if we could find this other side here, that would help us be able to find what this is. So the first thing we're going to do is we're going to use our Pythagorean theorem. Okay, because here's our C. So 16 plus 25 gives us 41. And if we take the square root, we're just going to go to the nearest tenth. Okay, so that's that little part. Now it says create an equation that can be used to determine X. So now I can set up a proportion because these are similar triangles. If one triangle is in another triangle and it's using the same sides, then it's similar. So I had to find what this was because I know what this side is of the bigger triangle. So now I can set it up. I can use, since I want this part of my bigger triangle, I'm going to use this part of my smaller triangle. So I don't need the 5. I needed it to find my hypotenuse of that smaller one, but I don't need it for this one. So I'm just going to set up a proportion. I'm going to go 26. I'm going to do the larger over the smaller. So 26 over 6.4, those are our hypotenuses, equal, and the larger one, that side missing is x, over the smaller one, 4. So when I multiply these out, I get 6.4x equals 104. I'm going to divide this by 6.4. Okay, so x is about 16.25 feet. So here's what this is, because we found our x. It says discuss any assumptions, so we discuss that we assume this is a right triangle. We also discussed this one in class, but let's go back over it. So it says Marcella drew each step of a construction of an angle bisector. Even if you don't know how to construct an angle bisector, it's given you the steps. It says angle Z is given in step 1. Describe the instructions for step 2 through 5 of the construction. Enter your description in the box provided. So this would be one you type out. We went through and we said, hey, what's different from step 2 that's not in step 1? So we're going to say step 2. We have this arc. So we're going to say draw one arc through, and we can't just say through the angle. We've got to list our rays here. So we've got ZB and ZA now. So we're going to say ZB and ray ZA. Now you're going to have to use these little symbols, so be careful on your tools and figure out where those are. So in step 3, what did we do? We put the point of compass on A and made an arc between the two rays. Okay, so step 4, because they intersect, that new little arc where C is intersects, we keep our same setting on our compass. So we would say keep same setting of compass as step 3. So we don't want to move our compass. And then we're going to put point of compass on point B and make arc between the two rays. But we want to make sure that we're doing it in the right spot. So we'll say intersecting the ray, or I'm sorry, the arc made in step 3. I know this is a lot of words, but guys, it'll be okay. It's not going to hurt you. Okay, step 5, what's different? Well, they use a straight edge, and they made a ray from Z through C. So use a straight edge, because those are our only tools we can use, are the compass and the straight edge for constructing. Use straight edge to construct or to draw a ray from Z through, so we don't want to say to C because that means it stops at C, so we're going to say through C. There you've made an angle bisector. Now Marcella wants to explain why the construction produces an angle bisector. She makes a new step with line segments AC and BC added to the construction as shown. Using the figure, prove that ZC, that ray ZC, bisects angle AZB. Be sure to justify each statement of your proof. So we know that if something is bisecting, like so if we had a segment that's bisected, any point on that bisector, so if we had a segment and we have a bisector here, any point on this bisector is the same distance from the endpoints of that segment. So it's going to mean the same thing about an angle. So if AC and BC are the same length, we know that this ray bisects it. It's the same distance from the sides of the angles. So if we did that, we could say BC and BA, or we can say congruent, that's a good word, is congruent to BA, which says, or we don't have to say which. So therefore, there we go. Therefore, ray ZC is equidistant. There's our word. There's a math word. Equidistant from both sides of the angle C must be on the angle bisector.